Hi, my name is Michael. I'm with Kemco System Service Department. Today we're going to talk about a 1 million BTU vapor mic. Alright, and we're going to discuss a couple important parts of this, starting with utilities, which are very important because this is what's going to be hooking up your equipment in the beginning. We're going to start first with the water utility feeding this equipment. You follow me around? On the back of the machine over here is where your main water utility will hook up to. This is your main water utility disconnect valve. We require minimum 40 to 100 PSI maximum dynamic pressure at this point here. We also require that you have soft water. If not, we will provide a water softener for you, or maybe one was provided with your system in the beginning. We will cover that at another time. Okay, we're going to follow down the water train right now and identify some parts. Okay, here's our water train coming on in. This is our main water regulator. This is where we're going to feed the 40 to 100 PSI dynamic water pressure to. Water pressure is very important that we have constant water pressure. If we do not have constant water pressure to the machine, it will result in inconsistent output temperatures that may not be desirable for your product. So, very important, we need to have constant water pressure to this regulator. If not, there's two choices. One would be a booster pump that we could quote for you, or possibly a separate holding tank pump fed to the machine. We can discuss that at another time. All right, let's identify the parts. We have the main water regulator here that we talked about, 40 to 100 PSI dynamic pressure. This is your water pressure gauge. This is what you will adjust your main regulator at. I would like to see between 45 and 55 is a comfortable number. Like I said, it all depends on if your water pressure fluctuates. If the water pressure does fluctuate a lot, you could go out on low water pressure, which is our safety here. This is the low water pressure switch. This is designed, if you do lose water pressure, we would like the machine to shut down so we do not burn it up. This is usually set at 18 PSI, so you see we're way above the threshold. It's setting it at 45 to 55, not a problem. All right, we'll move on. This little green guy over here is what is known as a pilot water solenoid. Okay, here you go. I'll get a little better picture over here. There's two ways that solenoid will open. One is when the machine turns on and calls for water, it'll open that, allow water to flow to the machine. If not, another way that we can open that, which will be discovered in another chapter, is the water prime button up here. If we push this button in, it'll turn that solenoid on, and that is for priming water through the machine when we first start this up. That'll be covered in the startup section, not the utility section. All right, now we're going to move on down the line, okay? And we follow our line through. This little silver guy right here is what is known as a flow control. This allows a certain amount of water to go through the water train and into the machine continually. Above it, we have a flow control needle valve that we actually use for temperature control for the machine. This is how you adjust your temperature for your output steam. Turning it in clockwise will decrease the water flow, thus will increase your output steam temperature. Vice versa, if we turn this knob counterclockwise, we let more water flow through, it'll lower your steam temperature down. All right, now we're going to move on forward where the water goes to. Okay, the water is going to come on into water-cooled elbow. This is a double jacket elbow to have longevity of the product and the elbow so we don't burn it up. Water goes in here on the bottom, fills up in here, keeps it nice and cool. Try to give you a little better view on that. Comes out of the top. All right, we covered the water-cooled elbow, very important part. And now we'll come up this hose right here and go into what is known as the mixer burner head, which will be covered again in another section. Nice water cooled, so we keep it nice and cool, keeps the head from burning up, gives a good lifespan on it. Water goes inside, goes around inside. Once it goes around, it'll now come down this hose. This is the combustion chamber. Okay, water goes into the bottom of the combustion chamber, fills up. The combustion chamber is basically a coffee can inside of a coffee can. It's got an interior wall space of about that much, about an inch. Okay, what happens is water comes in the bottom, flows up to the top right below this plate, rolls over, gets mixed in with the hot air gas from the combustion. Then it will come through the water-cooled elbow and out the static mixer, which is our final mixing part of the water, air, and gas. Thus, steam comes out here. All right. And we have a very important part of this that we want to show you. Notice that this combustion chamber has to be level. Very important. It has to be leveled both ways, front and back, left and right. The reason why is what we talked about, is that the combustion chamber has got an interior lining. If it's off one side or the other, one side will be dry. If it is not leveled, you can ruin the combustion chamber by cracking it, the water-cooled elbow, or cracking the static mixer, which will have to be replaced and will void your warranty if it is not leveled. At this moment, I believe that concludes our utilities on water.